Imagine a ship so massive it stretches longer than 3 football fields. It carries more than 5,000 sailors, dozens of fighter jets, helicopters, millions of liters of fresh water, and enough supplies to operate like a floating city. Every single day, it launches aircraft, powers thousands of onboard systems, and sails across some of the roughest oceans on Earth. An ordinary ship of this size would burn enormous amounts of fuel every day. But a nuclear aircraft carrier can operate for more than 20 years without refueling its reactors. How is that even possible? What powers one of the largest warships ever built, and why don't all ships use the same technology? Today, we'll explore the incredible engineering behind nuclear aircraft carriers and discover how a machine the size of a small city can keep moving for decades with no conventional fuel stops. To understand why nuclear aircraft carriers are so extraordinary, we first need to look at how conventional ships operate. Almost every large vessel at sea, from cargo ships and oil tankers to destroyers and cruise liners, depends on massive diesel or gas turbine engines. These engines burn enormous amounts of fuel every single day to keep thousands of tons of steel moving through the water. A modern aircraft carrier weighs more than 100,000 tons. Pushing something that heavy across the ocean requires an incredible amount of energy. The faster the ship travels, the more resistance it faces from the water, and the more power its engines must produce. For most ships, that means carrying thousands of tons of fuel on board. During long deployments, naval vessels often need to be resupplied at sea by specialized replenishment ships. These carefully coordinated operations allow fleets to stay at sea without returning to port, but they also require time, planning, and additional resources. Fuel isn't only used to move the ship. Large vessels also need electricity for radar systems, communications, navigation equipment, lighting, freshwater production, air conditioning, kitchens, medical facilities, aircraft maintenance, and hundreds of other systems operating around the clock. On a conventional ship, every kilometer traveled and every hour at sea consumes more fuel. That constant need for refueling has shaped naval operations for more than a century. So how can a nuclear aircraft carrier avoid this limitation for decades? The answer lies deep inside the ship, in a technology unlike anything found on ordinary vessels. At first glance, a nuclear aircraft carrier doesn't look very different from any other large warship. It has a massive flight deck, powerful engines, and thousands of crew members. But hidden deep below the waterline is the technology that changes everything. Instead of relying on giant diesel engines or gas turbines that constantly burn fuel, a nuclear aircraft carrier is powered by nuclear reactors. These reactors don't burn oil. They generate enormous amounts of heat through a process called nuclear fission. Inside the reactor are fuel assemblies made from specially prepared uranium. As uranium atoms split apart, they release an incredible amount of energy in the form of heat. What's remarkable is that this process produces millions of times more energy per unit of fuel than burning conventional fossil fuels. That heat is transferred to water circulating inside a closed system. As the water becomes extremely hot, it creates high-pressure steam. The steam is then directed toward massive turbines spinning at thousands of revolutions per minute. Those turbines perform 2 critical jobs. First, they turn enormous propeller shafts that move the entire ship through the ocean. Second, they generate electricity for nearly every onboard system, from radar and communications to elevators, hospitals, workshops, and even the catapults that launch fighter jets. Unlike conventional ships, the reactor doesn't need a constant supply of fuel delivered by tanker ships. As long as the nuclear fuel inside the reactor remains effective, the carrier can continue operating across the world's oceans for years. In other words, the heart of an aircraft carrier isn't its runway, it's the nuclear reactor hidden far below the deck. At this point, you might be wondering something that seems almost impossible. If every car, truck, airplane, and conventional ship eventually runs out of fuel, how can a nuclear aircraft carrier keep operating for more than 2 decades without refueling its reactors? The answer lies in one of the greatest advantages of nuclear energy: its extraordinary energy density. A surprisingly small amount of nuclear fuel contains an enormous amount of usable energy. Unlike diesel fuel, which is burned and quickly consumed, uranium releases energy through nuclear fission, a process that extracts vastly more energy from the fuel over a much longer period. Modern U.S. nuclear aircraft carriers are designed so their reactor cores can operate for many years before requiring replacement during a major overhaul. Exactly how the reactors are built and operated is not publicly disclosed, but their long service life is one of the defining advantages of nuclear propulsion. This means the ship doesn't need to stop for routine fuel deliveries like conventional vessels. Instead, it can remain at sea for extended deployments, limited mainly by food supplies, spare parts, maintenance needs, and crew endurance, not by reactor fuel. Fresh food, aviation fuel for aircraft, ammunition, and replacement equipment still need to be delivered regularly, but the ship itself doesn't require conventional fuel to power its propulsion system. That difference changes everything. Without the constant need to refuel its engines, a nuclear aircraft carrier can cross entire oceans, respond to crises anywhere in the world, and remain on station for months at a time. It's not unlimited power, but it's one of the longest-lasting propulsion systems ever placed inside a warship. If nuclear propulsion is so powerful, so efficient, and can operate for years without refueling, why doesn't every cargo ship, cruise liner, or naval vessel use the same technology? The answer is surprisingly simple. Nuclear reactors offer incredible advantages, but they also come with enormous costs and complex requirements. Building a nuclear-powered ship is dramatically more expensive than building a conventional vessel. The reactor itself, the shielding, specialized safety systems, and highly trained personnel all add significant cost before the ship even enters service. Operating the ship is equally demanding. Every reactor must be continuously monitored by specially trained crews, and maintenance requires strict safety procedures. During major overhauls, the ship may spend years in specialized shipyards while its reactor systems are inspected and upgraded. There are also legal and logistical challenges. Many commercial ports around the world have restrictions or special procedures for nuclear-powered vessels. Not every country is prepared to support ships with nuclear reactors, making global commercial operations far more complicated. For cargo companies, nuclear propulsion rarely makes economic sense. Commercial ships usually follow predictable routes, can refuel at major ports, and prioritize lower construction costs over maximum endurance. Military forces, however, operate under very different conditions. Aircraft carriers may need to deploy anywhere in the world with little warning and remain at sea for extended periods. For them, independence from conventional fuel is a major strategic advantage. That's why today, only a small number of military vessels, primarily aircraft carriers and submarines operated by a few nations, use nuclear propulsion. For almost every other ship, conventional engines remain the more practical choice. By now, it's clear that nuclear propulsion allows an aircraft carrier to stay at sea for years. But endurance is only part of the story. The true advantage of nuclear power is the enormous amount of energy it can continuously provide. An aircraft carrier isn't just a ship, it's a floating military base. Every second, thousands of systems operate simultaneously. Powerful radar arrays scan the skies hundreds of kilometers away. Communication networks connect ships, aircraft, and command centers across the globe. Massive elevators move fighter jets between the hangar and the flight deck, while workshops, hospitals, kitchens, and desalination plants operate around the clock. Launching modern fighter aircraft also demands tremendous energy. On newer U.S. carriers, advanced electromagnetic launch systems accelerate aircraft from zero to takeoff speed in just a few seconds. Each launch requires a large burst of electrical power delivered with remarkable precision. Unlike conventional ships, a nuclear-powered carrier can generate vast amounts of electricity while continuing to sail at high speed. This gives it the capacity to support advanced sensors, communications, and future technologies without depending on frequent refueling for propulsion. And the future may demand even more. As naval technology evolves, aircraft carriers are expected to support increasingly power-hungry systems, making a large onboard energy supply an even greater advantage. This is why nuclear aircraft carriers remain among the most capable and technologically advanced ships ever built. Not simply because they can travel for years, but because they carry an extraordinary amount of power wherever they go. For more than half a century, nuclear aircraft carriers have represented one of the greatest achievements in naval engineering. While most people see the towering flight deck and powerful fighter jets, the real innovation lies deep inside the ship, where nuclear reactors quietly generate the energy needed to keep an entire floating city in motion. These ships don't ignore the laws of physics. They simply rely on a technology capable of producing extraordinary amounts of energy from a relatively small amount of nuclear fuel, allowing them to operate for years before their reactors require major servicing. Of course, aircraft carriers still need food, aircraft fuel, spare parts, and thousands of dedicated sailors to keep every mission running. But when it comes to propulsion, nuclear power gives them a level of endurance that conventional ships simply can't match. It's a reminder that some of the world's most impressive technologies aren't always the fastest or the loudest. They're the ones that quietly perform extraordinary tasks every single day, often far beyond the horizon. If you enjoyed this documentary and want to explore more incredible engineering, military technology, and hidden secrets from around the world, make sure to subscribe. Thanks for watching, and we'll see you in the next documentary.